In this video, we are going to solve question number 31 of Tifr 2021. Here, the addition of HCl to 1 butene and 2 butene gives the same product. The rate of 1 butene reaction is faster due to. क्वेश्चन पे हमको बोला गया 1 ब्यूटीन एंड 2 ब्यूटीन पे HCl का एडिशन हो रहा है, तो ये दोनों क्या करेगा, ये दोनों कंपाउंड हमको सेम प्रोडक्ट देगा, पर रेट ऑफ द 1 ब्यूटीन रिएक्शन इज फास्टर। इसका रीजन क्या होगा? तो पहले हम लोग यहाँ पे जान सकते हैं कि क्या हो रहा है रिएक्शंस पे। सो दिस इज आवर 1 ब्यूटीन एंड दिस इज आवर 2 ब्यूटीन। ओके, तो जब 1 ब्यूटीन पे हम लोग रिएक्ट करेंगे बाय HCl, तो हमारे पास क्या बनेगा? हमारे पास एक इंटरमीडिएट बनेगा और वो भी 2 डिग्री कार्बोकैटायन। ठीक है, मतलब ऐसे हमको एक इंटरमीडिएट बनेगा। और 2 ब्यूटेन पे क्या होगा? 2 ब्यूटेन पे भी हमको एक इंटरमीडिएट बनेगा एंड दैट इज आल्सो अ 2 डिग्री कार्बोकैटायन, राइट? सो हियर वी कैन से द इंटरमीडिएट और वी कैन से द transition state, because initially there will be a transition state and that will be like this. Here H plus, okay, here Cl minus, or if HCl is free in medium, so definitely we can say that the transition state will look like this one. Okay, so here it will be delta plus, here it will be delta plus in this carbon. Okay, here also if we look at the transition state, then that will look something. Here it will be partially double bond character and it will be H delta plus here and it will be delta plus here also here. So we can say that in both of the cases there will be like 2 degree carbocation, or if we further go then we can find out that it will be definitely a 2 degree carbocation. Here it is also a 2 degree carbocation, right? So both of the cases has the same transition state, or we can say same energy intermediate. Okay, and that is 2 degree carbocation. Now if we look at the energy profile diagram, look at that. Now what will happen? We have chloride minus as a nucleophile, so these will attack and here these will attack. Okay, so after all we get the 2-chlorobutane, right? So let's go to the energy profile diagram here, and that will look something. Here it is, and here it will be the reaction coordinate. Okay, and it will be the energy. So we have the same intermediate, or we have the same energy transition state. So let us suppose this is our energy of the transition state. Okay, that contains electron deficiency at carbon number 2. Okay, both of the cases. And where is our reactant? We have two types of reactant, this one and this one, but which is more stable or which has lesser energy? Definitely this is more stable, because here more number of hyperconjugating hydrogens are present. Okay, so due to hyperconjugation this will be more stable, thermodynamically more stable, but this molecule has only 2 hyperconjugative hydrogens and it has 6 hydrogens, right? hyperconjugative hydrogens. It has two hyperconjugative hydrogens, right? This is why the 2-butene is more stable. So in our energy profile diagram, 2-butene will be placed in the low energy and 1-butene will be placed at the higher energy. Okay. So now here we can see that this is our energy states and this is transition state, and okay, we can ignore it here, or okay, so we have the same product. Okay, we have the same product, so we have no interest about the product. To deal with the reaction rate, we only deal with the energy difference between the transition state and the reactant. And now here we can see that the energy difference between the transition state and 1-butene is this one. That means the activation energy for 1-butene. This is for 1-butene, and this is for 2-butene, right? Okay, and this is TS. So we can see here that the energy difference between the transition state and 1-butene is this one. Okay, and the energy difference between transition state and 2-butene is this one. Okay, so which is higher in energy, or where the energy difference is large in this case? So 2-butene will react slowly, but 1-butene will react fastly. Okay, so which options we have? 2-butene is energetically higher than, okay, so the rate of 1-butene reaction is faster. तो इसका रिएक्शन जो हो रहा है वो फास्टर क्यों हो रहा है? बोला गया 2-butene is energetically higher. क्या 2-butene energetically higher है? Definitely not. It is energetically lower. So ऑप्शन ए तो गलत बोल रहा है, बिल्कुल गलत बोल रहा है. ऑप्शन बी को देखते हैं. 1-butene is energetically higher than 2-butene. यहाँ पे देख सकते हैं कि 1-butene energetically higher है, और इसमें क्या हो रहा है? हायर होने के वजह से ही इसका जो ई है, एक्टिवेशन एनर्जी है, वो क्या है? कम है कंपेयर टू दिस 2-butene. So this is why 1-butene is energetically higher than 2-butene. So B here will be the right answer. So let's check the option number C and option number D. Nucleophilic attack of Cl- is hindered. पर इसमें ऐसा कुछ भी नहीं होता, कुछ भी हिंड्रेंस नहीं होता. ऑप्शन नंबर डी क्या? फॉर्मेशन ऑफ मोर स्टेबल कार्बोकैटायन बाय 1-butene. दोनों में 2 डिग्री कार्बोकैटायन जनरेट करते हैं. तो फॉर्मेशन ऑफ मोर स्टेबल कार्बोकैटायन बाय 1-butene ये भी गलत है. दोनों में सेम कार्बोकैटायन जनरेट होता है और भी 2 डिग्री. तो हमारे पास आ गया ऑप्शन नंबर बी, व्हिच इज द राइट आंसर. थैंक यू सो मच.